Is there a technical reason no 10 GB USB 3.1 Gen 2 adapters exist yet? For example, it is practically impossible to create FireWire adapters over USB because FireWire needs to know which USB doesn't provide. Is there a similar blocking technical reason as to why no 10 gigabit Ethernet adapters appeared using the USB-C port, but not Thunderbolt? Giga over USB 3.1 Gen 1, and even USB 2.0, is everywhere. Is there something in the 802.3n standard that blocks this? I understand the economic situation here, that the more expensive laptops with USB-C also are Thunderbolt 3 capable, and it's somewhat unlikely the owners of cheap ones will want a 10 GB adapter. This question, however, is about the technical reasons, as the economic argument can be countered with USB-C being much cheaper than Thunderbolt 3, but again, let's leave that argument for different sites.
I will have another shot at answering, this time being explicit rather than implicit. For example, it is practically impossible to create FireWire adapters over USB because FireWire needs to know which USB doesn't provide. Is there a similar blocking technical reason as to why no 10 gigabit Ethernet adapters appeared using the USB-C port, but not Thunderbolt? There should not be any reason why 10 GB cannot exist. The 2.5 GB and 5 GB USB controllers by Aquantia and Realtek are proof that in GT, 1 GB adapters can and do exist. 10 GB over USB could come, but as I said, after overhead, 10 GB/S USB looks more like 6 GB/S. There is also the matter that the vast majority of USB controllers are bottlenecked by usbc because vendors do not wish to sacrifice 4 usbc 3.0 lanes for 2 ports, making it even worse. I have seen plenty of dual-port USB 3.1 Gen 2 controllers, 20 GB/S total, backed by usbc 3.0 x1, 8 GB/S. Thunderbolt 3 controllers are the most common USB 3.1 implementation that is not bottlenecked and can provide full 10 GB/S USB, but as we know, if you have Thunderbolt 3, then there is no point. As somebody mentioned, the bottleneck never stopped them making 1 GB USB 2.0 adapters, but these were made because it was still an improvement in speed over 100 MB/S adapters. Because 10 GB over USB looks more like 6 GB/S, they are more likely to make 5 GB adapters, as they did. The only advantage of making a bottleneck 10 GB adapter over a full 5 GB adapter would be connecting to 10 GB switches without MBASE-T support at NGT, 1 GB speeds. This will go away with USB 3.2, 20 GB/S over USB-C, but the issue where the USB controllers tend to be bottlenecked will only get worse. USB has poor latency. It might not be as critical for Ethernet as it is for graphics processing units, but when doing 10 GB/S, it might still make a difference. Even with my Thunderbolt SanLink 3N1, Windows struggles to get 10 GB/S down the pipe. Linux does it without even flinching, so maybe that is a driver issue. I have seen people comparing the Apple Thunderbolt 2 to gigabit Ethernet adapters to USB 1s and saying that the Thunderbolt T1s are more power efficient and use less CPU. This would be 10x noticeable with 10 GB. When the 5 GB USB adapters finally hit the shelves, I am sure somebody will test and compare the overheads, CPU usage and power efficiency with the Thunderbolt or the pure MBASE-T cards. Then we will know for sure. Power consumption is an issue, because of the large distances they have to support. I am fairly sure that over short cables, 10 GB does not consume nearly as much power. My SanLink 3N1 can use about 9 watts for the Ethernet controller and 2 watts for the Thunderbolt subsystem, according to the manufacturer, Promise Technology. Thunderbolt 3 ports guarantee 15 watts for bus-powered devices, but USB comes with no such guarantees. The manufacturer would probably receive a lot of complaints about problems which are caused by inadequate power provided by some, or many, ports. They would need to provide a supplementary power input which would make the product less desirable because of decreased convenience and portability. People would not take to it well, because every single USB Ethernet adapter in the past has been powered from the bus. Things that are USB-only like bus usually have a critical dependency on USB, not only for performance, but baked into how their drivers are written and how their physical interface is built. The only USB bus are display-linked chips, and they are not really bus, they are just taking a frame buffer from the CPU, us with a kernel mode driver and turning it into a video signal. On the other hand, USB Ethernet has existed for a very long time and has finally scaled to 5 GB/s, which should imply that it can scale further in the future. Giga over USB 3.1 Gen 1, and even USB 2.0, is everywhere. Is there something in the 802.3 and standard that blocks this? The reasons I discussed are not technical in the sense of being prohibited in the standards or being almost impossible to work around. There is no technical reason barring the possibility of a true 10 GB USB adapter, but there are too many practical problems for manufacturers to be interested. I understand the economic situation here, that the more expensive laptops with USB-C also are Thunderbolt 3 capable, and it's somewhat unlikely the owners of cheap ones will want a 10 GB adapter. This question, however, is about the technical reasons, as the economic argument can be countered with USB-C being much cheaper than Thunderbolt 3, but again, let's leave that argument for different sites. The technical reasons that are present are not insurmountable, but without mainstream adoption, demand, the manufacturers likely believe that the cons outweigh the pros. USB 3.2, 20 GB/s, should tip the scale somewhat with stronger pros by allowing for 10 GB without a bottleneck, assuming the controller is backed by enough USB lanes, but it could take a long while for an adapter to be released for USB 3.2 as adoption will be slow. I do not know if you consider practical and economic limitations to be the same thing, as in, not technical limitations. If this answer is not adequate, then you will need to clarify some more exactly what you are asking and what form the answer would take.
Here are the official announcements for USB 10-based T-Fizz. Aquantia, AC111U and AC112U, this URL. Realtek, RTL8156, this URL. As far as I can tell, products based upon these ICs are yet to make it to become available on the shelves, but it should not be too much longer, I hope. It is worth noting that Aquantia's AC111U will be bottlenecked by USB 3.1 Gen 1. Although it uses 5 GB/s USB for 5 GB/s Ethernet, there will be overheads. I presume the overheads will be similar to those when using USB SSDs for file transfer, resulting in about 280 MB/s over 480 MB/s USB 2.0. which is about 58% for use or 42% overheads. This is from how I observe a maximum of about 35 MB/s on USB 2.0. Somebody can correct me if this is a bad assumption. Either way, they should have used USB 3.1 Gen 2 for 10 GB/s for the AC111U and USB 3.2 for 20 GB/s for a hypothetical future 10 GB USB adapter. The AC112U and RTL8156 are unaffected as they are only 2.5 GB adapters and 5 GB/s USB should not bottleneck them. As usual, it is worth noting for readers who happen to have Thunderbolt 3 ports on their computer, that there are already a good number of 10 GB adapters for Thunderbolt 3, some of which are portable and bus-powered. Thunderbolt 2 will not work with bus-powered devices as the Thunderbolt 2 to Thunderbolt 3 adapters do not deliver power. The only way would be to daisy chain through a powered Thunderbolt 3 dock. If Thunderbolt is not an option to you, then I guess you are still interested in the topic of this article. It's just worth mentioning as not everybody is totally aware of Thunderbolt and might not have realized it is an option to them.
$10 GB to USB will not be made. Few reasons today. $10 GB takes too much power, like over 10 watts, so can't meet USB power specs. And no retail electronics company wants to make a plug-in USB dongle. Market too small. Maybe some boutique stuff, but then you're looking at $200 plus. Also, I don't think any chip vendors are building a cost-effective single chip or two chip solution. Chicken or egg. Not big enough market because of power consumption to invest because end product would not be big enough market. 10 GB also requires Cat 6A or Cat 7 cables. Won't work on Cat 5/5E/6/6E. New cables needed, again making potential market smaller, consumers buy without reading the fine print equals returned. There are Thunderbolt 2 and 3 to 10 GB options. Thunderbolt can deliver more power. 15 watts. These are $200 to $350 depending on what you want. Google 10 GB Thunderbolt and you will see stuff from Sonnet, Promise, and Arkitio. They work well with MacBooks and Win machines with Thunderbolt 2/3. I have used both Thunder 2 and 3 options. Also, Thunderbolt is serialized PSI-2ND/3RD Gen, so driver is similar to PSI card. USB is a more CPU-intensive driver, but that's a different discussion. But good news, coming out late in 2018 is USB to 0.5/5 GigE. 2.5 and 5 GigE are part of two new middle steps recently added as part of NBASE. 2.5 and 5 gig will work on existing cables. Well, maybe not Cat 5, but 5E or better. These USB dongles are from Aquantia chips. Google Action AC111U. These can fit within the used 3 power budget. I think 5 watts aka 5VX1A equals 5 watts. I am excited about these as I need multi-gig, but don't need 10 GB for what I am doing.
I've yet to find even one adapter that uses a USB 3 for 10 GB, so I think the following applies to both Gen 1 and 2 USB 3.1. The USB 3.1 Gen 1 and Gen 2 terminology is confusing here. USB 3.1 Gen 1 is a subset of USB 3.0, therefore existing chipsets simply meeting certain speed classifications are called USB 3.1 Gen 1. USB 3.1 Gen 2 is a separate specification requiring a different connector. While I can't speak to the efficacy of market availability of such adapters, it's most likely because you're comparing USB's maximum data signaling rate to Ethernet's signaling rate. In effect, this means the vast majority of USB 3.1 Gen 2 devices don't get anywhere near 10 GB/s. Therefore, it just makes more sense to use PCIe. Note that PCIe isn't that much faster per lane, but the card has access to many lanes. We'll talk when you find an X1 PCIe to 10 GB adapter.
If you want to watch the channel, please consider subscribing.